A commercial establishment, the question arises regarding the necessity of a main disconnect for a generator when the utility power, specifically the main disconnect, is located inside the building or structure. Referencing Article 700 of the National Electrical Code, (NEC), it initially states that overcurrent protection may not be required if the generator is within 50 feet or within line of sight. However, this allowance is subject to specific conditions, and a blanket interpretation can be misleading. Considering a commercial establishment where the utility power's main disconnect is located inside the building, a main disconnect for the generator is indeed required. This requirement stems from several fundamental electrical safety and operational considerations. Firstly, the primary purpose of a main disconnect is to provide a readily accessible means to energize the entire electrical system fed by the generator. This is crucial for safety during maintenance, repairs, or in emergency situations such as electrical faults or fires. Having a main disconnect allows personnel to quickly and safely cut off power from the generator, preventing potential electrical hazards. Secondly, the location of the utility's main disconnect inside the building influences the generator disconnect requirement. When the utility disconnect is inside, the generator effectively becomes a secondary source of power within the building's electrical distribution system. This necessitates a dedicated disconnect for the generator to ensure that it can be isolated independently from the utility supply. This isolation is vital for preventing backfeed, where the generator's power flows back into the utility grid, creating a hazardous situation for utility workers and potentially damaging equipment. Thirdly, the NEC provides detailed guidelines for emergency systems, which often include generators. Article 700 specifically addresses emergency systems and their power sources. These systems are designed to provide essential power during utility outages to ensure the safety of occupants and the continued operation of critical equipment such as fire pumps, emergency lighting, and life support systems. Given the critical role of emergency systems, the NEC mandates robust safety measures, including the provision of readily accessible disconnects for generators. Fourthly, the 50-foot or line of sight exception mentioned in Article 700 is not a universal exemption. It typically applies to smaller, simpler installations where the generator is close enough to the equipment it serves that a separate disconnect is deemed redundant. However, in a commercial setting with a complex electrical distribution system, this exception is generally not applicable. The complexity and potential hazards associated with such systems necessitate the additional layer of safety provided by a main disconnect. Fifthly, local electrical codes and regulations may impose additional requirements beyond those specified in the NEC. These local codes often reflect specific regional conditions or concerns and may mandate a generator disconnect regardless of the generator's proximity to the equipment it serves. Therefore, it is crucial to consult with local electrical inspectors and authorities to ensure compliance with all applicable regulations. Sixthly, the installation of a generator disconnect must comply with specific NEC requirements regarding its type, location, and accessibility. The disconnect must be rated for the voltage and current supplied by the generator and must be readily accessible to authorized personnel. It should be clearly labeled to identify its function and the equipment it controls. Furthermore, the disconnect must be installed in a location that is protected from physical damage and environmental hazards. Seventhly, the generator disconnect should be located in a place that is easily accessible during an emergency. This typically means placing it near the generator itself or in a location that is clearly marked and easily found. The disconnect should not be obstructed by equipment or materials that could impede access during an emergency. Additionally, the disconnect should be positioned so that it can be operated safely, even in adverse conditions such as darkness or inclement weather. Eighthly, regular maintenance and testing of the generator disconnect are essential to ensure its proper operation. The disconnect should be inspected periodically for signs of damage or corrosion and should be tested to verify that it functions correctly. Any necessary repairs or replacements should be performed promptly to maintain the reliability of the generator system. Ninthly, the size and type of generator disconnect required depend on the generator's capacity and the specific requirements of the electrical system. The disconnect must be rated to handle the full load current of the generator and must be suitable for the environmental conditions in which it is installed. In some cases, a circuit breaker may be used as the disconnect, while in other cases, a dedicated disconnect switch may be required. Tenthly, the presence of a transfer switch does not negate the need for a main disconnect at the generator. A transfer switch is a device that allows switching between the utility power and the generator power. While it provides a means of isolating the generator from the utility, it does not serve the same function as a main disconnect. The main disconnect provides a means of completely de-energizing the generator for maintenance or in an emergency, regardless of the position of the transfer switch. The NEC Section 22 specifies the requirements for overcurrent protection and disconnects for generators. It emphasizes the need for protecting the generator against overloads and short circuits and for providing a means of disconnecting the generator from the electrical system. These requirements are intended to ensure the safety and reliability of the generator system. Another important aspect is the coordination of overcurrent protection devices. The overcurrent protection devices in a generator system, including the main disconnect, must be coordinated to ensure that they operate selectively. This means that the overcurrent device closest to the fault should trip first, minimizing the extent of the outage. Coordination studies are typically performed to determine the appropriate settings for the overcurrent devices. The installation of a main disconnect for the generator should be performed by qualified electricians who are familiar with the NEC and local electrical codes. A proper installation can create safety hazards and may violate electrical codes. It is essential to ensure that the installation is inspected and approved by a local electrical inspector before the generator system is put into service. In summary, while Article 700 of the NEC provides some flexibility regarding overcurrent protection for generators located close to the equipment they serve, a commercial establishment with the utility power's main disconnect located inside the building necessitates a main disconnect for the generator. This is crucial for safety compliance with electrical codes and the proper operation of the emergency power system. The generator's main disconnect should adhere to NEC 22 and be appropriately sized and readily accessible.